What's up, AV Macro? My name's Bobby Stevens, and I'm from U of D Jesuit High School. Sorry I couldn't make it to you tonight, but I'm going to talk about fractional reserve banking, T accounts, and the money multiplier today. Let's get into it. Alright, so with fractional reserve banking, we're going to start out by saying net worth equals assets minus liabilities. If you add liabilities to both sides, you get assets equals net worth plus liabilities. So that gives us reasoning to make a T-chart where each side is equal. We have on one side assets, and on the other side is net worth plus liabilities. Alright, so under assets we start with reserves, loan, and bonds. And under liabilities we have demand deposits. So say you go to your bank and you deposit $100. So their reserves, which basically means money on hand, goes up 100, and then they're responsible to give you back $100 if you ask for it. So demand deposits is $100. Demand deposits basically means how much they're responsible to give back to their depositors, and then reserves means how much is on hand at the time. But say the bank wants to make a loan for $80 to the restaurant opening on the corner. So they're going to take $80 out of their reserves, and they're going to have an $80 loan. So basically, they take out $80 from what they have, but now this restaurant owes them $80, so that's also an asset of theirs. So their reserves are now $20. Also, a bond is basically a loan given to the government. So when you buy a bond, really you're lending them money, and then they'll pay you back that money with interest later. So say this bank wants to make a $10 loan or a $10 bond. They're going to buy a bond. So it's going to be minus 10. I apologize for the space. They have $10 of reserves, and they have a $10 bond. Now if we add up both sides, they're still responsible to give the depositor $100. So they are a liability of $100. But then if you add our 10, 80, and 10, that also equals $100. Here's how banks make money. So say I have an $100 deposit to the bank. You go up to the bank, give them $100. And they want to make a loan for $80. So minus 80. Now they have $20 reserves, right? The loan is $80, but they're going to charge 10% interest on it. So they give out minus 80, but they're going to get the person receiving the loan is actually going to pay back $88 because they're paying 10% interest. Now if you add up both sides here, this side equals 108, but the net worth plus liabilities is still 100. What happened in the loan is that because the person taking the loan actually is being charged interest, the net worth is increasing by $8, and the bank now is the bank is valued. The bank has some value now, and so this side adds up to be $108. The bank gained in value. Alright, so in fractional reserve banking, banks are not permitted. Banks are not permitted to let go of all of their reserves and loans. But they can loan out a large amount of it. Say the required reserve is 20%. So they take their demand deposits and they have to keep 20% of that on hand at all times. So say they have 10 million, demand deposits equals like 10 million. That means that they have to keep 2 million on hand at all times. But they can loan out, required reserve equals 2 million, but they can loan out equals 8 million. That 8 million can actually go a long way because it can be loaned multiple times. I'll show you how. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so here's 10 squares. They have to keep 2 million on hand, and they can loan out the other 8 million, right? So required reserve and loan. Now that loan, it'll be going back into the market, and then say they loan it to a construction company. That construction company spends their $8 million loan on wood, and that wood, whatever the wood company is, they're also going to put it back into their bank. Now the bank can loan out that money again. So there's 1, 2, 3, 4, 5, 6, 7, 8. So now the bank has a deposit of $8 million. So they take 16 or 1.6 million, which is like just about there. That's the required reserve. And then they can loan out their 64 million again, and so on. So this money can be put back into the economy multiple times, and the total sum of money is actually given by the equation D equals ER times M, DERM. So the D stands for new demand deposits. The ER stands for excess reserves. And the M equals the money multiplier. I messed up. So the excess reserves equals ER equals demand deposits minus the required reserves. So basically, if the required reserve is 20% of 10 million, then the demand deposits equals 10 minus 2 equals 8 million. That's the excess reserve. AR equals 8 million. The money multiplier is given by 1 over the required reserve amount. So if the required reserve equals 0.2, money multiplier equals 1 over 0.2, which is 5. So now we take this back over here. The amount of new demand deposits that the loan gives out is D equals our ER equals 8 million times 5. The new demand deposits equals 40 million, just from that 8 million loan. So basically there's a time frame of money. Now that the money is loaned out, somebody owes that money back. And so when the money is loaned out, it's basically put back into the economy, and it creates money because it adds more money flow to the economy. Now when somebody pays money back, they actually destroy money from the economy. So loan creates money. But when they pay it back, it actually destroys money. The money was never actually printed or destroyed, but it just takes money out of the economy because you're paying it back to your lender. All right, guys, I hope this helps you guys understand more about fractional reserve banking, T accounts, and the money multiplier, and I'll see you next week.